Here's another example where we're going to use the base angles theorem about isosceles triangles in a proof, but in a slightly different way. So let's mark our givens here. We have B is the midpoint of AC, so that means those are the same, because B is the midpoint of AC. AX is congruent to CY, and BX is congruent to BY. Immediately we see we have SSS marked on these two triangles. So if we were trying to prove that these triangles are congruent, or if we're trying to prove some corresponding parts are congruent, then we would be done, we'd have it. But if you look at what we're trying to prove MA is congruent to MC. MA goes all the way here, and MC goes all the way here. So we're trying to get all the way up. And these are not two sides of these little triangles. Now, one thought that students sometimes have, and this is incorrect, is they say, well, we know AX is congruent to CY. Let me make a little note, this is wrong. We know AX is congruent to CY, and then if we just add XM and YM, like this, like we've done before, AX plus XM gives me AM, and CY plus YM over here gives me C to M, and we've got it. I've added XM to AX to get AM. There's XM, AX, and I've added YM to CY to get CM. Well, what's wrong with this? Well, what's wrong is we do have a reason for this congruence. That's a given, but we don't know this congruence. XM congruent to YM. It's not part of our givens. We have no obvious way to deduce it. So until we know that this is true, we can't guarantee that this would follow by adding. And so this won't work. It's the wrong approach. What you have to realize here is in asking you to prove that MA is congruent to MC, you will notice that MA and MC are two sides of the same triangle. So if I could prove that this triangle were isosceles, then I would get this. I would get MA congruent to MC. And remember that the way isosceles triangles works is if you can get two congruent angles, then you can deduce that it also has two congruent sides. And that's what we're going to do here. We can't directly prove using these triangles that MA and MC are the same, but what we can prove using these triangles is that this angle and this angle are congruent. Those will be corresponding parts of these little triangles. And then these angles not only are corresponding parts of these little triangles, but they're also a pair of angles in the big triangle. And so if I look at the big triangle, since this big triangle ACM has two congruent angles, it must also have two congruent sides. That's the base angles theorem, and that's how the proof will go. So let's do the write-up so you can see how it looks in the write-up. So first of all, we're going to have our SSS proof to prove that the triangles are congruent. I'm going to do triangle ABX is congruent to triangle CBY. That's going to be by SSS. And then I put above here my pair of sides that I have. And this is just AB congruent to BC and AX congruent to CY. This is my second pair of congruent sides in SSS. And then BX congruent to BY. That's my final pair of sides in my SSS argument. This is because of the midpoint statement. These were both given. So I've shown that these two triangles, triangle ABX and triangle CBY, are congruent. Because they're congruent, this angle here at A in this triangle must be congruent to the angle at C in the other triangle. Those are corresponding parts, corresponding sides. And then switching to the bigger view, those two angles that we knew were congruent because they're corresponding parts of the small triangles, they are at the same time a pair of congruent angles in this one big triangle. And so, by what we've learned about isosceles triangles, if a triangle has two congruent angles, then the sides across from those two congruent angles must also be congruent. So I may conclude, because angle A and angle C are congruent, that the sides opposite of those two, MA and MC, are also congruent. And that's using this argument. Two angles in a triangle congruent implies two sides congruent. And so that will be my last reason. And that's how that proof goes.